In this lesson, you will learn how to identify arithmetic and geometric sequences. Recall that a sequence is a list of numbers in a particular order. First, I'm going to talk about arithmetic sequences. So, in an arithmetic sequence, the numbers change by adding a constant value. This value is called the common difference, which we represent with the letter D. So let's just take a look at a sequence of numbers. Let's say you had 4, 7, 10, and 13. This is an arithmetic sequence of numbers, and we find the common difference by subtracting any two consecutive terms. So 4 is the first term, 7 is the second term. So if I wanted to find the common difference, I would use subtraction. 7 minus 4 equals 3. So that means the common difference for this arithmetic sequence, or D, is 3. And as you can see, each of these terms increases by 3 from the previous term. When you graph an arithmetic sequence, what you get is a straight line. And the reason you get a straight line is because of this common difference. The common difference is like saying there's a constant rate of change. And if you recall, the slope of a line the slope of a straight line is a constant rate of change, which is what we have here. The common difference is the slope of the line when an arithmetic sequence is graphed. Now let's talk about geometric sequences. In a geometric sequence, the numbers change by multiplying a constant value. Now this value is called the common ratio, and the letter that we use for the common ratio is R. So let's just take a look at an example of a geometric sequence. Say you had the numbers 1, 4, 16, and 64. This is a geometric sequence, and to find the common ratio, you would divide any two consecutive terms. So let's divide the second term of 4 by the first term of 1, and this will give us the common ratio. 4 divided by 1 equals 4. So that means R equals 4. This sequence is made by multiplying each term by 4. And as you can see, this is how the numbers increase here. Unlike arithmetic sequences, geometric sequences are not linear when they're graphed. So let's take a look at a problem, and we'll identify whether or not we have a geometric or an arithmetic sequence. I'm just going to scroll down so we can start this problem. So I'm going to give you some terms, and then I'm going to give you the values. So let's talk about, okay, we're going to have term. We have 1, 2, 3, and 4. So this is the first through the fourth term. And down here, we're going to talk about value. So for the first term, you have a value of 189. For the second term, you have a value of 63. The third term is 21. And the fourth term is 7. So this is we'll just make a table around this so we can keep track of all the numbers separately. All right. So now we have our terms, and we want to know is 189, 63, 21, 7. That's our sequence. Is this geometric or arithmetic? The terms, right, the first, second, third, fourth term, these are all at equal increments. You can almost think about these as like X values or your input values. Now these are going up by 1 each time. Now let's take a look at the value of the term, or you can think about it as the output or Y value. Let's compare the consecutive Y values in the table. For this to be an arithmetic sequence, each term is found by adding a constant value to the previous term. So let's see if this works. Let's try and find the common difference. And by trying to find the common difference, we're trying to figure out if this is an arithmetic sequence. To find the common difference, you would take the value of the second term and subtract away the value of the first term. So let's try and find D. 63 minus 189 gives you a difference of negative 126. Now let's see if this constant value holds for the next two terms, right? So now let's subtract the third term and the second term. The third term is 21, and we're going to subtract away the second term, which is 63. If this is an arithmetic sequence, we will get the same value for D. 21 minus 63 equals negative 42. Now, these two values do not match each other, which means this sequence is not generated by adding the same amount or the same number to each term. Another way you could have tested this would be to say, okay, we have a second term here of 63, and I found my first common difference I thought would be negative 126. If I took 63 plus d, or that value I thought was the common difference of negative 126, I should generate the third term if this were an arithmetic sequence. But 63 plus negative 126 equals negative 63. And the third term is 21. So this is another way to check that you were correct in assuming this was not an arithmetic sequence because you did not generate the same value for d in between two different consecutive numbers. So now let's try and test this out for a geometric sequence. If you recall, the geometric sequence is found by multiplying the previous term by a constant number. So let's divide the second term of 63 by the first term of 189. So I'm going to do this one down here. So let's see if we can find a common ratio of r. 63 divided by 189, if you simplify this, you get the simplified fraction of 1/3. So now let's apply. Let's see. If I multiply 63 by 1/3, do I get the third term of 21? Let's try that. 63 times 1/3, which is really the same as saying 63 divided by 3. And when you do that, 63 divided by 3, you get 21. And I'm just going to check it one more time because I was able to generate the third term accurately. Let's see if I can get the fourth term. So that means I would take the third term of 21, multiply by the common ratio of 1/3, which gives me 21/3, and 21 divided by 3 equals 7, and that's the value of the fourth term here. So now I know that this table represents a geometric sequence, and I know that because each term is generated by multiplying by a constant ratio, or r. And in this case, the constant ratio was 1/3. In this lesson, you've learned how to identify arithmetic and geometric sequences. Thanks for watching.